Hello, I'm Mrs. Jacobson, and today we're going to talk about 13.3 and 13.4, at least the first half of it. It's concavity and higher derivatives and sketching a curve. So what the higher derivative means is to just take the derivative more than once. Now you could have a 2 tick marks, that means the second derivative. 3 tick marks means 3 derivatives. After that, they start putting the number 4 or 5 or 6. It'll have the number. So if we look at this one, it's asking for the second derivative. So you take the first derivative, four times 3, so 12x squared plus 10x minus 6. Well, it asks for the second derivative, so it'll have 2 tick marks. 2 times 12, 24x plus 10. Now this means take the second derivative and plug in 0. So we take this and plug in 0 and get 10. This one means second derivative, plug in 2. And that gives us 58. This one is saying the third and the fourth derivative. So if this is our function, the first derivative is 15x to the fourth minus 12x cubed plus 6x squared plus 14x. Second derivative. 4 times 15, 4, 5, 6, 60. X cubed minus 36x squared plus 12x plus 14. Third derivative. 180x squared minus 72x plus 12. This would be the third, which is what they asked here. Then the fourth is 360x minus 72. If you had to do it again, the fifth is just 360, and the sixth would be 0. So it's just taking the derivative again. Now, of course, these were just polynomials. You could just imagine if you had a quotient rule and you had to keep taking it. You would definitely need to be able to simplify. Okay. Why is the second derivative important? Well, the second derivative finds the point of inflection. The point of inflection is where concavity of the curve changes. So if it's bending this way, down, but then at this point here, it starts bending up, that's where your concavity changes, the bend of the curve. So this is concave down, this is concave up. Down has a frown, if that helps you remember it. So that's from the second derivative. If we look at this, then we're going to find the first and second derivative so we can see where it's increasing and decreasing in concave up and down. So the first thing we need to do is take the derivative. Negative 3x squared minus 24x minus 45. And the second derivative, take the derivative of this, negative 6x minus 24. We need to set both of these equal to 0 because this gives us our critical numbers. This gives us the x value for the point of inflection. Setting this one equal to 0, I'm going to divide by negative 3. Oops, I don't need the parenthesis. I'll get x squared plus 8x and it will factor x plus 5 and x plus 3. These are the critical numbers. I'm going to mark critical points down here. We'll put them down at the bottom. We also need to find the point of inflection. To find the x value for the point of inflection, we take the second derivative and set it equal to 0. Add the 24 over and then divide by the -6 and get a -4. So these are the x values. To find the y values, you plug them into the original. But since we're going to graph it, we can just go to the table. So first we want to plug this in and use this window and graph it. I think I already plugged it in. Let's just double check. -x cubed minus 12x squared minus 45x plus 2. Then go to our window, -8, 3, 1, -1, and 60. And there's our graph. So it goes whoops, I'm kind of off a little here. Kind of like that. And these points where it's decreasing, increasing, those two where the increasing and decreasing change, those are the critical numbers. They were the -5 and -3. So this low one and this high one, that's the critical. It's a little off, but. And then here where the concavity changes, that's my point of inflection. So this is going up, and then here it starts going down. So intervals increasing and decreasing. We start out decreasing from -infinity to -5. And then from -5 to -4, we're increasing. And then we decrease again from -4 to infinity. Whoops, it was 3. The critical numbers are -5 and -3, so it's -3 where it starts decreasing. I usually don't write the critical number in there till afterward. I mean the point of inflection, or I put it on top. So this is where the concavity changes. These two are where increasing and decreasing change. So -infinity to -5, it comes down. -5 to -3, it goes up, and then it comes down again from -3 to infinity. The concavity only changes in one spot. This one, it's concave up. So it's concave up from -infinity to -4. And then -4, it starts going down from -4 to infinity. And you're using x values. To find these values for the points, just go to your table. That's up here, second, and the graph button. And we need to plug in -3, -4, and -5. -3 gave us 56, -4 gave us 54, and this one gave us 52. So these two are where the increasing and decreasing, and then this is where the concavity changes. And that's it for the first part.